Dear students, I welcome you all to Future Focus. In this class, we would be studying chapter Principle of Mathematical Induction of Mathematics of class 11. Now, let us start our chapter. For solving these problems of mathematical induction, first, you need to take the statement of the form Pn, and you need to first check for n is equal to 1 if it is true or not, and then you need to let it is true for n is equal to k. Now after that you need to check if it is true for n is equal to k plus 1. So let us take an example to solve these problems. So you have given a problem of statement of the form Pn as this: 1 plus 3 plus 5 plus 7 and so on till 2n minus 1 equal to n square. Now let us solve this. First, we are taking this given statement as Pn, right? Then you need to check if n is true, if Pn is true for n is equal to 1. In that case, LHS would become 2n minus 1. In placing n equal to 1, you would get 2 minus 1, that would be 1. And in RHS, you would get 1 square, that would be 1. So LHS and RHS are equal. So you would get P1 as true. Now, you need to let that pk is also true. For that purpose, pk would become this whole statement. Instead of n, you place k. So it would be equal to k square. Now, you need to check if n is equal to k plus 1 is true. Now, put n is equal to k plus 1. On simplifying this term, you would get your term would be 2k plus 1. The term previous to 2k plus 1 would be 2k minus 1. Since there is sequence of odd numbers. So, in place of this whole term, you would be placing this value of k square, right? So, it would become k square and 2k plus 1. Now, you know that a square plus 2ab plus b square is equal to a plus b whole square. So here your polynomial given formed is k square plus 2 into k into 1 plus 1 square. So here a is your k and b is your 1. So it would be formed as k plus 1 whole square. I hope this identity you have learned in your previous classes and it would be clear to you. So you would get k plus 1 whole square as the solution of pk plus 1. Now your RHS would also become, on placing k plus 1, it would be k plus 1 whole square. So both LHS and RHS are equal. So this shows that pk plus 1 is true whenever pk is true. Thus p1 is true and pk plus 1 is true whenever pk is true. Hence, by principle of mathematical induction, Pn is true for all n belongs to n. Now, I would request you to pause the video and solve these problems based on the previous example and solve these problems yourself and then proceed to this video. I hope you have solved these problems. Now, I'm continuing with this video. Now, another problem is when there is square. The polynomial Pm is of the form of square. So your Pn would be, this would be your Pn, right? It is of the form this. Now you need to check for n is equal to 1. So P1 would be LHS 1 square, that would be 1 in LHS, right? In RHS, so it would be 1 by 6 into 1 into 1 plus 1 into 2 plus 1. So this would become 1 plus 1 is 2 and 2 plus 1 is 3 into 1 by 6. So 3 to the 6, this would cancel out. This would be 1. So 1 and 1. LHS and RHS are equal. Now you need to let it is true for n is equal to k. If it is true for n is equal to k, then I'm sorry, why this pen is not working. Pn. Pk value would be Pk would be 1 square plus 2 square and so on till k square is equal to 1 by 6 k into k plus 1 into 2k plus 1. Now you need to check. Third step would be you need to check if it is true for n is equal to k plus 1. Now for LHS, 1 square plus 2 square plus 3 square and so on till k plus 1 whole square. So you can see here there is increase of one term, that is 1 plus 1 2, then 2 plus 1 is 3. So the term previous to k plus 1 whole square would be k square. And the value of this whole term we have already assumed as pk is true. So this value would be this whole value. Now let us place the value and solve this further. Now you would get your polynomial in this form. Let us solve it further. Here k plus 1 over here, k plus 1 whole square over here. So k plus 1 would get carry out, would get common, sorry. K plus 1 common, then you have 1 by 6 into k into 2k plus 1 plus k plus 1. Now let us take the LCM of this 6. So you would get k into 2k plus 1 plus 6k plus 1 whole divided by 6, and you have k plus 1 outside, right? Now let us simplify this term. So it would be k plus 1 and 1 by 6 outside, and inside you would be left with 2k square plus k plus 6k plus 6, right? Now on further simplifying, you would get 1 by 6 k plus 1, then 2k square plus 7k plus 6. By middle term splitting of this term, you would get 1 by 6 k plus 1 and this would be k plus 2 into 2k plus 3, right? I'm solving this term by middle term, how we would be splitting. Now this 2k square plus 7k plus 6. Here multiplication we would get, on multiplying you should get 12, and on addition and subtraction 7 must be there. That's okay. So factors would be 4 3s are 12, right? So 2k square plus 4k plus 3k plus 6. So take 2k common from these two terms, 2k, then k plus 2. Now take 3 common from this, plus 3k plus 2. So from here, k plus 2, k plus 2, k plus 2 would get common. So you would get k plus 2 and 2k plus 3, right? This is how we are getting k plus 2 and 2k plus 3. Now let us solve our right hand side. Now let us solve our right hand side as n is equal to k plus 1. Here let us put n is equal to k plus 1 in this right hand side. 1 by 6 k plus 1, right? And k plus 1 plus 1, that would be k plus 2, and 2k plus 1. So 2k plus 1, that would be 2k plus 1 plus 1. So this would become 2k plus 2 plus 1, 2k plus 3. So this would be 2k plus 3 and this whole term. And it is matching with this term. So it is LHS and RHS are equal. So it is true for n is equal to k plus 1. Hence, by principle of mathematical induction, this statement is true for all n. So this is how you solve this problem of squares, when it is squares, right? Now let us come to our another problem when there is product of two numbers, like 1 into 2, 2 into 3, 3 into 4, and so on till n into 1. So let us check for n is equal to 1 if it is true or not. N equal to 1. So LHS would become what? 1 into 1 plus 1 is 2. So this would be 2. Let us check our RHS. So 1 by 3, this would be your 1 into 1, 1 plus 1 into 2, and 2 plus 1 into 3. So 3 would cancel out and you are left with 2. 2 equal to 2. So it is true for n is equal to 1. Now let us check for n is equal to, now let us assume that n is equal to 2 for n is equal to. You need to assume that n is equal to true, n is equal to k is true, right? So for that purpose, the pk would be 1 into 2 plus 2 into 3 plus 3 into 4 and so on till k into k plus 1 is equal to 1 by 3 k into k plus 1 into k plus 2, right? So let us check if it is true for n is equal to k plus 1. N is equal to k plus 1. So pk plus 1 LHS would be, your LHS would be 1.2 plus 2.3 and so on till k plus 1 and k plus 2, right? So you can see there is increase of one term. Here increase of one term, 1 ka 2 and 2 ka 3. So increase of one term. So the previous term would be k, the k plus, previous term of k plus 1 would be k, and previous term of k plus 2 would be k plus 1, right? Plus. So this whole term value already we have in this equation, right? So it would become this value plus this term. So in the RHS, you would get this term. Here, k plus 1 and k plus 2, k plus 1 and k plus 2, both would get common out. K plus 1 into k plus 2. And inside you would get 1 by 3k plus 1. That would be k plus 1 into k plus 2 and take 3 LCM. So this would be k plus 3 and 1 by 3 outside. So this would be your LHS. Now let us solve the RHS. So your RHS would become 1 by 3 k plus 1, k plus 2 and k plus 3. 1 by 3 in place of n k plus 1, so k plus 1. Then n plus 1, k plus 1 plus 1, that would be k plus 2. N plus 2, k plus 1 plus 1, and k plus 3. So LHS and RHS are equal. So it is true for n is equal to k plus 1. And it is also true for n is equal to 1. So by principle of mathematical induction, it is true for all n where when pk is true, right? It is true for pk plus 1 and 1 and where pk is true. Hence, this is how you solve these problems. Now, I would suggest you to again view the video. If any concept or any doubt is left in your mind, you can ask us in comment section below and we would hopefully solve your problems. Thank you. I would suggest you to like this video, subscribe us and follow our channel for more updates. Thank you all and have a nice day.